See it?
There's
Yeah.
32, but we, in theory, oh, no, we didn't
There's
do them already.
there's 32.
Yeah,
Yeah.
the homework
Yeah,
had
yeah, I was
26.
looking at it and I was like, oh, we're supposed to go over these like by ourselves and then do it as a group.
Oops.
Whoops.
That's not how I did it. It said in the homework, like, these are the same questions, do the homework. And so I did the homework.
Oh, you did the homework? So
Yeah,
yeah, you're good. See
but
where
there's
I
only
didn't see it till there's only what?
there's only 26 questions on the homework, so I'm missing a few questions.
Oh,
Hmm.
Anywho, question
hmm.
2.
Sorry, I'm opening it.
No worries.
Also, I went through a
Yeah.
breakup last night, so I'm like a little off today,
Oh,
not as prepared.
things didn't work out with that guy.
Yeah, he just wanted to push the boundary a bit. He's not LDS. And I was like, okay, so if I do this, then you'll want to push it to this. And then he's
Yeah,
like, yeah. And I was like, that's not going to work for me.
good for you.
And thanks. Honestly, not very easy, but oh well.
Yeah. Oh well.
Way to hold your standards.
Thanks. Yeah, not
Which I'm
easy.
curious. You'll have to tell me more about your background because you said you've been married twice.
Yeah, so it's not an easy thing for me to do.
Yeah.
Not at all. It's the worst.
Next week I'll have to
Yeah,
pry
we'll
some
we'll
more.
talk.
I'd
Yeah.
love to hear.
Okay. Given
100%.
90% confidence interval. Which
so
following?
that's B, right? So given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? And I have gotten these questions wrong a couple of times. And so I went to the review with the TA yesterday,
Mm-hmm.
and
Oh, you
like
did.
what's that? What did you say, Tanner?
We're just saying. We just said, oh, you did.
Oh
Nice.
yeah, yeah.
I
So
forgot
if
about that. Like,
yeah, I like saw the email. It was like 3:15. I was like, I should go. It was a good review. But so I think it's B, isn't it?
that would be my guess.
Okay, so he said a clue on this is that if it says chance, rule it out basically. Like if
Okay.
there's anything to do with chance, rule that out because that's talking probability. And then even the first one, A, and I hope I'm right about this. He said like 90% of all people have a heart rate between 45 and 105. That's talking about probability as well. And confidence intervals are not about probability.
That
So
makes sense. Well, and
that's
I
how you can
figured
read out those three.
we can't assume 90% of people have that kind of heart rate. I mean, we don't know what the test subjects were.
Yeah.
That's so I wouldn't go with A. I was gonna, yeah, I was thinking B.
Yeah. Cool.
Sounds
Okay.
good to me.
Uh,
Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no go stimulus of males differed from that of females, whatever that stimulus is. The researchers randomly selected 20 females and 15 males to participate. The go, no go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decide to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I think yes, because the distribution is normal.
agreed, which is C.
Yeah. Okay. Sorry to read so much.
No worries.
Okay.
Question 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Oh, this is something I need to study more on.
Yeah. So confidence interval for mean of differences using dependent samples. No, but they're independent. And
I feel like I took a screenshot of something.
confidence interval of mu and sigma is known. Unknown, and when it's known. For difference of means using independent samples. Oof.
So no.
I take screenshots of stuff sometimes when I'm in meetings. I'm trying
Smart.
to. Oh, okay. I took a screenshot of basically this exact question because I was like, oh, I need to study this, but I don't have like notes on it. I don't think. Let me see.
Yeah, I don't know. There was a couple on the homework that did this. I essentially just guessed.
Yeah. Seeing dependent samples. Okay. Yeah, it's like that exact question. Okay. So which one is appropriate for this? So basically, I think we need to figure out what kind of test we would do. So it's obviously, it's going to be a t-test because it's 2 samples. And so is it going to be paired or independent?
They're independent, right? Here, let me scroll up. Yeah, they're independent because it doesn't matter. The males and females aren't connected. They're not married. Essentially, they're just picking random 20 males and a random 15 males and 20 females. So I would say they're independent.
So I would be inclined to think it's C then.
Yeah, that was my guess.
Okay. Hopefully we're right.
We'll find out at the end. That's what I love about this. Like, oh, we get 6 chances.
Yeah, will it show us on this one what the right answer is? Or
Should, like, right? I mean,
I always get quizzes mixed up.
if we get it wrong, how are we to fix it and study?
Oh, no, you're right. Okay, cool. Cool. All right. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be this and this. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
I think it's B or D. Because lowering to 10 people is going to make it worse.
Yeah, exactly. And I don't think C is right.
Yeah, I don't think C is right either.
I think it's either going to be B or D. This is a tough quiz. Like, this is good prep.
Yeah.
I'm just trying to remember. Wasn't it if you add more people, it makes it?
Yeah, I think so. I'm going to.
But if you change the percentage.
Google which of the following. Oh, wait. What produces a confidence interval with a smaller margin of error? Okay.
Good question. Well, yeah, because I thought if you have more people, that means your error goes smaller.
That's what I would think.
It might be.
So you can increase the sample size. This is Google.
Okay, which is D.
Yeah, increase the sample size. Often the most practical way to decrease the margin of error is to increase the sample size. Reduce variability. The less that your data varies, the more precisely you can estimate a population parameter. Use a one-sided confidence interval, lower the confidence level. So actually it would not be 99%.
Right, because that's raising. Okay.
So it would be D.
Final answer, D.
Okay.
It would make it bigger.
Right? Yeah. Oh, and that makes sense because if you look at like the curve, like if you want it to be
the applet.
Huh?
Like if we use the applet.
Yeah.
Going to 95% would make it a bigger field.
Yeah.
Doing 90%, you said? Did you say making it what percent?
I didn't say a percent. I said it would make your field would be bigger because your area is shaded.
Right, but I was saying if you like take it down to 99%, that makes it like a lot narrower. Oh wait.
Well, I just pulled up the.
No, it's like an inverse relationship, I think. with that. But
Okay,
yeah,
Tanner.
I think it's D. What did you
I think
say,
it's D
Tanner?
too.
Oh, I was just saying I pulled up like the quantitative whatever worksheet, and yeah, I
Oh,
typed
okay.
in 99, and yeah, I went from 5, like one of the low I think it's the low one, went from 5 to almost 7. So yeah.
Oh,
But
okay.
yeah, we got it right. Yeah.
Nice. Thanks for
Yay!
checking that. That was a smart way to check
Yeah.
it.
Yeah, good call.
Okay. Sorry, I'm like on one right now. I took pre-workout before going to the gym, so I'm just like alert. Lots of
Not a bad
energy.
thing.
That's all right.
I wish I were.
Yeah.
Do you want to read, Tanner?
Factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. He randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 100 millimeters. Are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts and put your answer. So
So
determine the margin of error.
I forget what is the formula for that. I think you program that onto your
The
Excel sheet, Catherine.
For the
Oh,
margin
the
of error,
margin of error. Yes.
yeah,
But isn't it?
let's
Don't we
see.
just take 2 millimeters as standard deviation, and then don't we subtract that from 1,000, and then add it to 1,000? Because the middle's 1,000, and our standard deviation is going to be evenly separated out by a number of points. Point number 1 being,
Is
was
that
it?
what margin of error is? It's the sample mean plus or minus the standard deviation?
Oh, I don't know.
That
Well,
doesn't sound right.
no, the margin of error is you take the um, high interval minus the low, and then divide that by 2.
Oh, okay, thank you. I couldn't remember. High interval.
But yeah, no, but yes, I agree with you 100%. I'm just saying that if the interval was 10 and the mean was right in the middle, you would take 10 divided by, or one side divide minus the other side and divide that by 2. That would give you how far spaced the thingies are, right? Those red lines.
I don't know. Let me
Because those
see.
red lines on the applet thingy, we're trying to find out where they're at, and we know that they're going to be on the deviation. Those are my words.
Yeah, I don't know on this one, but we'd better figure it out.
Well, in the homework, because it gives you the same question, but it gives you options.
Yeah.
Let's see if I can find it.
How to determine margin of error.
It's question number 5 on the homework. So,
95 confidence.
She had many that she takes, right? She just takes random.
what?
It doesn't say like, yeah. I was
Yeah,
talking
she
to myself.
selects randomly 4 drive shafts.
Oh, here it is.
Yeah, and then we take standard deviation, we subtract 2, and we add 2. Is my understanding, and that's how it is in the homework.
Well, here, I'll show you this page. Let me share my screen. So I found a thing. Looking into eternity.
A thingy. Yay.
So I just Googled it, how to calculate the margin of error for a sample proportion. And it's this formula, I think. So the Z would be, so I think, let me get some scratch paper. So it'd be 1.96 times, and it's like the square root of, what is that, the sample mean? Is that what that is? Like the
P?
Well, it looks like, is that
Here's,
what it is?
I printed out,
Where P is the sample proportion.
proportion, yeah, because she printed out, or she sent us the table of statistical symbols. Statistics, so population proportion.
What is that?
Oh, great question.
That doesn't
That'd be
sound familiar to
1,000.
me. Google, what is the sample proportion? The sample proportion is the fraction of samples which were successes.
But we don't know that.
Mm-hmm.
Oh, wait.
Well,
Yeah, it's 4 drive shafts. So it'd be
That's
4.
the sample size, isn't it?
That's sample size. Yeah, you're right.
So plug that in for N. I don't know if we're on the right track.
I don't. If you look at the homework, though, question 5, it gives you answers. So we know it has to be one of these A, B, C, or D's.
Oh, okay.
I'm telling you, I think we subtract 2 millimeters from 1,000.
Probably do.
And then we add, because the thousands in the center, and our deviation.
So are you saying you think it's 998 and 1,002?
101.9. Or, yeah. Although I would say it's.
But then where does the 95% confidence interval factor in? Because I feel like that's relevant information.
It's the
that should affect your lower bounds and upper bounds.
I think that's what we're trying to figure out, what the lower bounds and upper bounds are. Should we get Sister Lemon?
We could, yeah. Did you have her phone number?
I do.
Oh, okay. Would you mind? Por favor.
Nope. Math. Oh, the baby.
Cute.
Yep.
Is your wife in school too?
No, she just works.
Gotcha.
Yeah, so she's been taking the baby to her parents' house.
Oh, that's so nice.
The baby to what?
Your parents' house.
Oh, nice.
Yeah.
Grandma must love that. Oh, I decided to call her. Oops. I was going to text. Hold on.
Why does it have to be so long?
Well, in the meantime, I guess we can. Oh, I was like, this is on my Facebook, sharing my screen.
Oh, you're fine. I wasn't showing up on it. You weren't making so it wasn't big.
Sorry to interrupt. Okay.
That's so funny.
We just need to send her a link. I just talked to her husband.
Okay, cool. I guess we can move on to another question if we want. And put the lower bounds. I think.
Hello? Woo! I just talked to the hubby.
Yep.
She said send her a link.
Oh, okay, nice. Oh wait, that's me because
You have the link.
But she'll hop on right now.
Okay, cool. Let me send it to Lemon.
Jeez, holy.
Oh my gosh, I wish more teachers did this.
I'm kidding. She's like next level.
I think the school is slowly purging the unwanted and bringing in the next levels. I would hope so. I mean,
yeah, same. Okay.
Scrolling through this, it's like all the same. It's like find the upper value, p-value.
Yeah.
I'm telling you, I think we just subtract.
Probably do. You're probably right.
But I feel like just subtracting the standard deviation, that doesn't seem right to me, because then it's ignoring like the confidence interval, like the 95%.
But it goes like 98, 95, and then 60 something.
Oh.
So we subtract it 2 times.
Oh, I get what you mean.
So it'd be 996 and then the 104. Yay!
Right.
Good morning.
Hello.
How are you?
Good. How are you?
Good.
Thank you, husband.
I know. I know, because I had it on silent, so I didn't hear it.
Yeah. Some random person calling.
Which is totally good. I'm glad you picked it up.
Yeah.
Same.
So we're stuck on question 6. We've had some debate. I think we're making it bigger than it is.
Yeah.
You bet you are. So hold on. Let me just open up the quiz.
You're probably right, Catherine.
Sorry. I'm not always right, and I don't always speak up, but I really think it's that easy.
Take the candy to work and get rid of it. Let me take the candy to work and just get rid of it.
Yeah, that'd be awesome.
We'll take some candy.
I know that the problem is that I keep eating it.
Yeah. What does your husband do?
He is in the produce industry.
Very cool.
Interesting.
Yeah, he owns a little organic salad company.
Oh, no way.
Awesome.
That's so awesome.
Okay. Let's see.
Next time we're in the area, we'll check out your salad company.
You can buy it at, oh, I know it. Okay, so I think what happens on this question, did you get question 7 and 8?
No,
not yet.
We're
Okay.
at 5.
Okay.
6.
So,
we're at 6.
Okay, so what happens is, I think what happens is we get so used to finding the margin of error and the lower bound and the upper bound by using our Excel spreadsheets that we forget how to do it the longhand way. Because when you're given the population standard deviation, you have to go through z-scores. And if you have to go through z-scores, we don't have a spreadsheet that's been pre-programmed for us. You could create one, but by the time you created one, it'd be a lot easier just to do it manually.
We can sell it to the other students and make some money.
Yeah, well, it's actually, you probably could. Okay, so let me just show you. So you just have to kind of go old school. So again, one of the context clues as you get ready for this exam is you want to make sure if you see in the information that they've given you the value of sigma, either they tell you, by symbol sigma equals, or they tell you the population standard deviation is this, or then you are, then you're dealing with a Z situation. So I'm just going to share this my screen with you for a second.
Wait, would you mind saying that again? So if sigma is
if we know sigma, so they've either said to us, they either gave it to us by symbol. They've said sigma equals, or they say it's sometimes they'll say the known standard deviation, and they're talking about the population information. But basically, that's often equivalent, not always. So you got to read the context. But if basically you're given the population standard deviation, I'll just put SD, then it is Z procedures.
You sent us these really cool hypothesis tests sheet. This sheet thingy, which was really nice. And so, can
This
we
thing
just
right here.
yeah? Can
Yeah.
we
Yeah.
we just use the z-score there for?
Well, we're doing. I didn't. That's just to find the z, but we're doing a confidence interval. So you
Oh, that's true.
remember. So when we're doing a confidence interval. Now this is general. For every confidence interval, you have a point estimator, and then it's plus or minus a margin of error.
Are you supposed to be sharing your screen? You're drawing a picture, I bet, and we're not seeing it.
I wonder why. So sad. Oh no, I'm not drawing. Can you just see that point estimator plus or minus margin of error? No, is it not coming through?
We just see you and your husband.
Are you serious?
Mhm.
Okay. Well, that's weird because it says I'm sharing my screen, so I don't know what the heck. Okay. Desktop. Okay, let me try this again. Okay, now can you see it?
No.
No. What?
You said for every confidence interval, you have a point estimator and something else.
Okay, hold on just a second. I'm gonna.
Okay.
Oh. Kidding. Okay, I'm gonna share my screen this time. See if it works. I'm like talking to myself. Okay, so let's just now Google. Okay.
There it goes.
Oh,
Nice.
it's blackness.
Maybe it's black.
It's the dark.
Okay. All right, now can you see it?
No.
It's just black.
Oh, wait.
There it goes.
There it
There
is.
we go.
Okay. Okay, Google Hangouts has not been my friend of late. I don't know what it is. I think it knows I use Zoom or something. Okay, so if you are given a sigma value, the symbol, or if they use the terminology, the known standard deviation, basically in a reference to telling you the population standard deviation, that means you are going to be using Z procedures.
Plus a margin.
When we do.
Sorry, go ahead.
So your confidence interval is a point estimator plus or minus a margin of error. And basically when we use the Excel spreadsheets, it's doing all this for us. It's building this for us, and it just spits out a lower bound value and an upper bound value. And we're like, oh, thank you very much.
It's done.
But when we're doing with procedures, it's not been pre-programmed in Excel, and so you got to do it manually. So your point estimator when you're dealing with the Z procedure for quantitative is an X bar, and then your margin of error is the Z asterisk, and then times the standard deviation of the sampling distribution. And the sampling distribution standard deviation is made up of the population standard deviation divided by the square root of n. And then we, so if you're not positive, what a 95 is, remember you shade the middle, go into the Z, this normal probability applet, which is Z scores, and you pick up that Z asterisk is 1.96.
Okay.
Follow?
Yes.
So this becomes plus or minus 1.96 times, we're told the sigma is 2, sample size is 4, and this is 1,000.
Okay.
And so what this is doing is really this margin of error is shifting back into the units of measure, in this case, millimeters. So this is 1.96 standard deviations. That's telling me that'll cover the middle 95%. And now let's take the value of a standard deviation and get back in the unit of measure. So when I do the math here, technically this is 1.96, but it's not standard deviations. It's now in millimeters.
Right.
This is
so then we subtract 1,000 plus 196, and then 1,000 minus.
Yeah. So your lower bound will be the subtraction. Your upper bound will be the up bound. And this 1.96, after I've done the math, this is my margin of error.
Okay. So the Z-score plus or minus is the margin of error, or just?
Yes, yes, this whole piece right here that I was drawing all by myself that you couldn't see before earlier, that whole piece is the margin of error.
Oh, so we do have to times 1.96 by the 2
Yep.
divided. Okay, that's why I was like, wait a second.
Yeah, yeah, because the Z is just telling me, hey, how many standard deviations do I need to go left, right to cover the middle whatever percent, you know? And then I got to change the unit measure, because remember, Z's in unit measure standard deviations, and I need to pull it out of unit measure standard deviations and multiply it by the value of the standard deviation to get back into the unit measure associated with the data. So that's what this is doing.
Awesome. So the answer for 6 would be 1.96.
Correct.
And the lower bound, if we subtract, would be 998.04.
Wait, Sarah's typing something in Excel.
That's okay.
What were you saying?
I said the lower bound, 1,000 minus 1.96 is 998.04.
Upper bound
And
is
the upper bound is
1002.
well, it'd be 1001.96. Because we're adding 1.96 to 1,000.
Mm-hmm.
Oh, so it's 1001.96?
Yeah.
Okay.
So I had part of it right.
What am I going to do?
Yeah, you did.
2.
What?
What am I going to do? 1002.96.
So this is 1,000 plus 1.96 and 1,000 minus 1.96.
Oh, whoops, that's what.
Wait, and so then the margin of error is what?
1.96 is our margin of error.
Oh. Oh, I thought we had to. Okay, I got confused. I thought we still had to. I thought we had to take 1.96 and then like times it by.
You did? Yeah, you do. So you multiply it by 2,
Okay,
divide by square root of 4, but
Yeah.
that's really just a multiplication of 1, because 2 divided by square root of 4 is 2 over 2, which is 1. That's what makes it kind of confusing. So that's why.
Okay.
Yeah.
So for this particular one, it is.
Yes. Yeah.
Oh, okay.
But that technically
Thank you.
your margin of error isn't 1.96 standard deviations. It's 1.96 millimeters, because you've done that multiplication. So it's transferred it to. Does that make sense?
Yes.
I think so. We'll see.
Well, yeah, they don't do a lot, but you do have to remember how to do it technically longhand. And we can do, when we have T procedures, we can do those longhand as well, but we would rather just use the Excel spreadsheet and shortcut it. But you can do it long.
No.
So, and then what happens in Unit 2 is we do so much of it, quote, on that shortcut, because we have this output table, that we forget how to do it technically the way the true way you have to build it, because we're like, oh, somebody already built it, because you're just like, oh, it's in Excel, and you're like,
plug and chug.
Exactly. But somebody actually built it the way we just long-handed it. But because T's a pain in the neck, because the value of T, like for a 95% confidence interval, is different depending on the degrees of freedom. It's like constantly changing.
Oh, okay.
And so it becomes more of a pain to deal with, and that's why you usually use programs. You have someone else who's programmed it to say, oh, the end's this, so T's this. And so, but I think in this class, they want to say, hey, so you know how it gets built, here's how to build it. So for all Z procedures, you're going to do everything manually and only be able to use the Excel spreadsheets when we're doing T procedures for quantitative data.
Okay. Cool.
Yeah. What was my other question? Is it okay to add a sheet to the quantitative inference procedures workbook for margin of error? Is that like kosher if we have that and we're using it on the test?
Okay, so you totally cut out. So I don't. It
probably
sorry. Was only me. Sorry.
Is it okay if we add a page or add a sheet to the quantitative inference procedures workbook about margin of error and just put the formula there, or is that not okay to use on the test?
Oh, I see what you're saying. Yeah, just add that piece onto. I think so. I mean, it's like as long as you're programming, that means you know what you're doing. So
Yeah.
right? Does that make sense? So
Yeah. Okay,
so
cool.
you're just adding a piece right next to the confidence interval output. Is that what you're saying?
Yeah.
Yeah. I mean, you did the math, right? I mean, you said, hey, you're subtracting up or down minus lower bound parentheses and then divide by 2. So I don't know. I haven't heard that song. I was the one who got in trouble because I was like, yeah, you can turn in your quizzes one at a time. And then they were like, oh, no. I was like, then you need to have it so that I learn only makes you fill in the one problem you got wrong.
Yeah.
Because I didn't see it as that big a deal. I was like, it's saving everybody from refilling out the thing. And I'm like, look, the reality is it's not like they go, oh, we got it wrong. Let me, you pick A, I'll pick B, you pick C, you pick D.
Right.
And then that's how we're doing the quiz. So I was like,
Well, we kind of did that the other day.
Oh wait, we did, I guess, on one of them because we were like legitimately like working hard to figure it out.
Yeah.
We weren't just like, oh, let's divide the risk.
Yeah. No, that's a strategy. So like I said, if it's not like, I'm totally checked out and we're just doing this, then that's a different story. So
yeah.
Okay.
Okay.
Keep going then.
Yeah, we need to keep going.
Yeah.
You're welcome to join us.
Yeah, that's
no pressure to stay though.
Yeah, we've been here for a while. I know, Tanner, you have to leave soon, don't you? We ended up starting late, waiting for Matt.
Yeah, I gotta leave probably about 5 minutes.
Ooh, and you're on question 9?
Yeah.
Yeah.
All right. Well, that's all the more reason to record it. Then Tanner, you can come back and finish it. And if you have a question, you can just look
that's what I was
okay.
thinking. Is that later I can just look over it.
Just email it out though, because you don't have to actually put this up on the discussion board. So just email it to him.
Oh, yeah.
Okay, we'll do that.
Will the link be the same, like the one that you sent out for the recording? Can I access that? Will it have that, or is it a separate link?
It's a separate link. So like after
Yeah.
I've concluded the recording, I'll send it out. Although one of the guys in my econ group said that YouTube, it like cuts off these HOAs at like around 30 minutes usually, even if it's longer than that. So hopefully
I bet they're doing that because that's I bet they're doing that to save some space, and that's what Zoom does if you don't have a pro account. Which you guys do have access to a pro account because you're with BYUI, but
interesting.
But I wonder if that's kind of now becoming the standard. It's like, hey, if you're doing it for free, you're only getting 30 minutes.
Right. Huh.
So I haven't read anything yet, but that wouldn't shock me because I think that that's what a lot of formats are doing, and that way YouTube starts making money. They're like, you want
more money,
all the features. You take this,
Although Google owns YouTube.
Exactly.
Yeah.
So it's just a money. It's just a way to make money.
Yeah.
If you want more than 30 minutes, you gotta pay. You gotta pay for an account. Okay, so question 9. So question 9. So again, read the information, and there's a huge context clue in there.
Okay.
To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with known mean and standard deviation. With unknown mean, thank you. Mm-hmm. And a standard deviation of 0.01 grams. How large should n be so that 95% confidence interval has, or for mu, is that right? As a margin of error of 0.0001. Okay, so do you see the context clue that's kicking? It's telling me exactly what if I'm using Z or T. You see it? You said.
Okay, go ahead.
When we're given just a little ago, if you said if we're given standard deviation, we use Z.
Yeah, well, population standard deviation. So not if you're given sample standard deviation, but population, and there it is. It gives you sigma equals 0.01. That is a huge red flag. I'm using a Z procedure. So if you, immediately you go, oh, I'm using Z procedures. And if you look on, you guys all have this downloaded.
Mm-hmm.
Okay, so note we have one group, sigma is known. And if you look down here, I've got the formula for you. If you want to find sample size, here's the formula.
Cool.
Okay. So Z times deviation 0.01. And we know Z would be 1.96. Is that right? Did I memorize that correctly?
Yeah,
For
1.96.
95, yeah.
And M.
Standard.
Yeah, if it's 95% and it's a Z, then yes, you've memorized it correctly.
Woohoo! And M is the margin of error. 0.0001. I have to make sure I get the right zeros.
Yes, you do. Don't mess up your answer.
Because I am that person.
I think we all are. So many Excel sheets. Okay. So this is equals.
So I got 384.16.
Times point. I'm still doing it. Sorry.
No worries. That
I
seems
think
awful.
you left out a 0.
I told you.
left out a 0.
Let me use the good calculator. 1.96 times
Wait, I have 196.
0.01 equals.
Is that right?
What?
I have
You
196.
should. Now you need to square that.
Oh, oops. Okay.
38,416.
Correct. Now this one, they gave you a really nice number. It came out to be a whole number, but just know if it doesn't come out to be a whole number, you
Round up.
Yep, this is the one time, no matter what the decimal is, you always round up. When we're dealing with sample size, we always round up.
Yeah, because you can't have a half a person. You have to have a whole
Right.
person.
Exactly.
So is it 38,416? Is that what you guys said?
Yes.
Okay, cool. Cool.
It's 8:03, Tanner. I don't want you to get in trouble.
Yeah, better go. I gotta
Good luck with
go
your
throw
interview.
on some dress clothes.
Yeah, let us know how it goes.
Yeah, Tanner, good luck, bud.
Yeah.
You're gonna kill it.
Yeah, hopefully.
Yeah.
Hopefully
Let
it
us
goes
know.
well.
Let us know if you have issues when you finish this on your own, and we'll try
Yeah.
to help if we're as much as we're able.
I can't help tonight. I have to do Relief Society thing, but I can help tomorrow.
And I will do my best. My brother's getting married tomorrow, so I'm going to be doing that all day.
There you go.
But
You have Stephanie
There you
tonight and me tomorrow.
yeah.
Okay. Yeah, I'll try and do it. Maybe, I don't know, I have to go up to camp it. Well, I have to go do my interview, go to class, go take
You're
a
busy.
test.
You're.
Then hopefully I'll have time in between that because then I got to meet with another group and do a time. So yeah,
Good luck.
I'm busy today. I'll be up on campus probably till like 10 o'clock tonight.
Oh, geez.
Oh, man. Enjoy.
Oh, to be
Yeah.
young
Right.
again.
All right.
right,
Well,
we'll see
thank
ya.
you guys.
So yeah,
Thanks. I'll see you next time.
See ya.
Bye.
question 10. The mean area mu, is that the upside down?
Yeah,
Of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hired an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are
I would say it's A.
but they're saying
Oh, wait,
it's
they think
bigger.
it's smaller. Sorry.
Yeah, they think it's smaller.
Yeah, so they think the mean is less than 1250. So it's D then.
Correct. That's what I got.
Okay.
Uh-huh.
Cool.
You're not
You'd
eating
be
more
totally
candy.
fine no, grapes. I'm eating some grapes.
Okay.
Oh.
Nature's
So I won't
candy.
eat candy. I literally bought a Costco thing of chocolate, different
Oh,
assortment. Yeah, and then picked out everything. I'm like, get this out of here.
Dangerous.
It's for me.
Yeah.
11.
I'm willpower. Not my thing. Okay, go ahead. Keep going.
A statistical test of
Tanner
hypothesis.
does not want to see this.
Yeah. Let's talk about chocolate.
Yeah. Hot
We-
topic.
Yeah, we say reject the null hypothesis when the level of significance, fish symbol, what's this one called again?
Alpha.
Alpha. If you
B.
said, and I wrote it down, when P is low, reject HO.
Oh yeah. Oh, that one actually rhymes because I was thinking it was if P is low, reject the null. I was like, that doesn't rhyme. I mean, it's the same
No.
thing, but yeah. But HO, that makes sense. So
B.
it's B. Yeah, cool.
Do you want to read?
Good.
Yeah. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped, so they're normally distributed. Wait, are they? Does that mean it is? Okay, with no outliers. Okay. And the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
I'm going to say yes, because they're normal.
Yeah.
It's not
Yeah.
just normal. It's
Right.
normal, and there's a variance requirement as well for
Right.
ANOVA.
Okay.
Right.
But they said that in there. They said the sample variances are nearly equal. And again,
that's
our tolerance for equal is that the largest variance is not bigger than 4 times the smallest.
Right.
Uh-huh.
Cool. So it's
that's
B.
why, yeah.
Yeah, I was just going to say, since we know they're normal, we could narrow it down to the 2 yeses. And then of the 2 yeses, D is clearly not the answer.
Yeah.
Because who cares about the kids' GPAs?
Right.
But yes, deduction.
Nice.
Question 13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after diagnosis is the same for new treatment and the standard treatment. In an early trial, so they're equals, the H's are going to equal. In an early trial, she tries a new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has
Committed a type 1 error, I think. Right?
Boom. Good job.
Okay.
Yeah.
Yeah.
This is my cheat sheet. That's how I have to do it. So I look at that and I'm like, okay, reject HO. HO is true. That's a type 1 error. So, I mean, again, so I'm a visual learner, so I have to do it all that way. So it's like, whoops.
It's nice to have a chart. Yeah.
Yeah. So that chart,
there we go.
Come together. That's a type 1 error. If I fail to reject and HO is false, that's a type 2 error. So that's how I do it.
Nice.
Cool.
But you can do it any way you want. But I'd suggest having something on your notes for the exam that it clearly makes sense in your mind how to figure out a type 1 and type 2 error.
Okay.
I like this. I'm just going to put that, because can we use these papers you gave us for the test? Like, we can just put that on there.
Yeah.
Cool. Awesome.
You're letting us use notes.
Yeah, it's
Appreciate
you get a page of notes. Yeah. Yeah, no, yeah.
All right. If the level of significance, alpha, is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It increases, doesn't
Agreed.
it?
That's what I thought. So A.
Yeah. Yeah, they go in opposite directions.
Yeah.
So
Whew.
if one increases, the other decreases.
Cool.
Nice. The nicotine content in cigarettes of a certain brand is normally distributed, with mean in milligrams, mu, and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measures on a random sample of 100 cigarettes of this brand gave a sample mean of X bar 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
So 0.05 is the level of significance. My brain isn't wanting to do stuff right now. Okay.
Okay, so again, first thing is, how many groups? You want to go through this, kind of talk to yourself. How many groups do we have?
We have one group.
Yeah.
Okay, so we have one group.
Yes?
Now get out that flow chart. The next question you ask. So once you know it's one group, now go to the green. And do you have
Sigma.
the next question you ask yourself is, do you know sigma or do you not?
We do. Check.
Okay, that means you're dealing with Z procedures. And if we're dealing with Z procedures, we're doing things manually.
Wah, wah.
Right? So no Excel spreadsheet for this puppy. So we got to go through that old school from Unit 1 where you draw your bell curve and you figure, or you find, and you got to find your Z-score, and then you got to find the p-value associated with your Z-score.
Okay.
You have to
Okay.
do all that.
Okay, so X is 1.53 minus
I
what
need
would
to
be-
find that.
what would be how do we know which mu
It's
to
right-
use?
Well, there's only one value for a mu. The other one's X bar.
Oh, they're 1.5. Duh. Sorry. And it's 0.1017 divided by the square root of 3. There's 3 samples. Is that right? 100 samples.
Yeah.
What
Which
do you-
is why they have about, oh no, what?
Stephanie, what are you looking for is what I was going to say.
Oh, I'm just opening up my notes so I have the formula and stuff. I think I am like a little out of it from last
print-
night.
Did you print this out, the sheet she gave us? It's in the...
I haven't.
Oh,
I don't have a
it's
printer.
right there.
Oh,
It's right at the very bottom, right here.
wait,
Yep,
what sheet
there
is
it
that?
is.
Sorry.
It's in the
It's on-
announcements.
Oh, okay. Yeah, I hadn't opened that just yet.
Okay,
Oh,
so here it is. There,
Yeah.
see right there, there's your Z.
Sorry, let me.
We don't
I
have a
like
colored printer,
Aha.
but
Well, you don't have to. I just
Oh,
did it. So
evening.
if you wanted to look on it online, you can just see the difference. So I could say, look
No,
at the
thank you. Wait, so
But-
it's the Z equals X bar minus mu?
yes.
One. Oh, yeah, I remember this. Duh. It's so funny
Yeah.
how even like a week away from something, it kind of gets a little
Mhm.
fuzzier. Good. So,
Well, and
Yeah.
we've been using those Excel spreadsheets for so long. Everyone's just kind of got that on the brain, you know?
Yeah.
And it's like, well,
so
don't
true.
forget.
Yeah. Okay.
So, and then we need to open up the applet too, right? Which, do I?
Yeah, I just opened that up.
Yeah, that normal probability applet.
We haven't used that in ages either. We got to dust it off.
1.53 minus Oh, so 1.5 is the mean. Okay.
Yeah.
Parenthesis divided by another parenthesis.
She likes to do it in Excel.
I do. But I have to watch the parentheses because on the first exam that
Yep.
messed me up a little.
That messed you up. Yep,
Mhm.
yeah, messed you up.
I do it by hand. I have less room
Yeah,
for
I do
error.
too, actually. I think I think I trust so bad, but I think I trust doing it by hand more than I do the Excel. I mean, Excel's I guess it's because I was a math major. I'm like, well, Excel didn't exist when I was in college, but
That's crazy. Yeah.
well, nothing did. It was just a black
Right.
screen. We were so excited when we got portable computers from IBM. They only weighed like 40 pounds, but they were portable. It was no longer, it literally was no longer because it used to be the server was in this room with all this air conditioning. There was one printer and this massive, like, I mean,
So crazy.
we just got out of punch cards, for crying out loud.
Mm-hmm. No, it's wild. Like, that really wasn't that long ago in history.
No,
like,
it wasn't.
and how dramatically it's changed.
Yeah. I remember when microwaves came out, and
I do too.
I remember when beta machines came out for tape recording, so you could watch a movie at your house.
I remember our first VCR and our first microwave.
Yes. I didn't get a microwave till I got married.
It's when you know you've
I
made
didn't
it.
get a dishwasher either.
Yeah. We take a lot for granted. Okay, so I got yeah. I got 1.765.
Yeah.
Okay. Hey, I watched my parentheses correctly.
Yay.
Okay. I'm just like hyper aware of it now, I guess.
That's a good thing.
Yes.
And so now we need, which area do we shade in?
So
well, what's that?
Greater than.
What's that? Yeah.
Oh yeah, it's greater than 1.5. So we need the far right. Okay, so 0.0388.
0.765. Oops. Wait, what did you get? 0.0388. So 0.0389.
Correct.
Okay.
Oh, and then now we compare it to
the level of significance.
Right, which is 0.05, and this is smaller, so therefore we reject HO.
Yeah. Cool.
Wait. Is there? Oh, there it is. Whew, it's D. I was like, I can't find it. There's not an option.
Okay, cool.
Okay. Woo! We should get extra points for that.
Yeah. For the same thing we've been doing all semester. Okay, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I would say an independent samples t-test.
I agree. Sister Lemon, does she?
Yeah.
Okay.
16, yeah.
Okay. Woo! Just waiting for.
You guys are doing great.
Okay.
Yeah.
Great.
I was like, we're trying.
Mm-hmm.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brothers and sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? Dependent sampling.
But B or D. The sister's academic achievement depends to some degree on her brother's academic achievement. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in the study. It's D, right?
I lost. Sorry, you guys cut out, but
yeah. No, I think it's D.
Yes. Yeah, D is correct. Yeah.
Okay.
Because you're right. It had to be dependent because you picked a brother, so the sister, you knew the sister was going to be in the other, so that makes it dependent. And what you're studying is the academic achievement got an association. So that's why B's not right. We don't know that there is. That's what we're studying.
Right.
So that's why we're doing the comparison. So we're selecting a brother, therefore we're selecting a sister to be able to do that comparison. So that's why it's D.
Makes sense. Okay. Soil scientists collected random soil samples from a field and measured the dissolved organic carbon milligrams per liter level of each sample. The measurements are recorded in this Excel sheet. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. So, did I open that one yet? Okay. Copy. And then, so this will be a one sample t-test. And so, are you guys there?
Yeah.
Okay, it just was like really quiet for a second.
I accidentally muted it.
Oh, okay, you're fine. So 95% and by the way, Sister Lemon, I don't mean to eat up your morning, so if you have to go, like totally,
No, I'm
totally
doing
fine
it.
too.
I'm doing it. It's clean house morning.
Okay.
You're keeping cleaning the house. That's very exciting.
Okay. Well, good. Let's see.
Well, we
Oh,
know
which,
sigma is unknown.
yeah.
So it's
A.
yeah.
Okay, I was like busy putting it in the sheet, and I was like, wait, I need to pay attention to like what the question's
Yeah.
asking.
I did the same thing, and then I read the question like, oh wait, so A.
Like I have the p-value. Wait, oh, I don't need that yet.
Not yet, but we'll need it in a second.
Yeah.
Following 95% confidence interval for this analysis, input your answers. Okay, margin of error. I got 2.2 or 2.025. 02.
Wait. So let me see.
Because we take the upper bound minus the lower bound.
Mm-hmm.
Yeah, so this is where you get to use your Excel spreadsheet and you don't have to do it manually, right?
Which is glorious.
Okay, so it's upper bound minus lower bound.
Right. Did you ever get the sheet I sent you? Because I have it just programmed into my Excel sheet.
Oh, I don't know if I did. So upper bound minus lower bound, and then what?
Divide by 2.
Divide by 2.
Mm-hmm.
So it's 2.025.
5. Yeah.
I'm going to reduce the decimal points there.
Although you could just mark it a formula in your sheet.
Yeah, that's what I just did.
Yeah, because it's not hard. Okay, and so the lower bound is 11.168. And the upper bound, 15.217. I love that, hey, we have it. You just plug it in.
Mm-hmm.
The downside is if you plug it in the wrong one, you have 5 answers wrong.
Like onto your Excel sheet?
Right.
Yeah.
Like, so that's where referencing cells is like really valuable. So instead of like, anytime you have an input that can change like the confidence interval, it's best to reference the cell instead of just plugging it in manually.
Yes.
Yeah. So
I agree.
So it's automatic. So we got A for that, and so margin of error is 2.025, right?
Yes.
Sorry, my brain is like
no worries.
Up. So 15.217. Oh wait, no.
Is the lower bound 11.168 and the upper bound 15.217.
15.217. 217. Cool, cool.
And
And then used Hummers
so let's,
in New
and I
York and LA.
now I remember with this, we have to remember which one comes first.
We want to know
Yeah,
if
anytime
it's-
you're dealing with two sample, because it's not that in the real world it's wrong, because you could define what you call group 1 or group 2. It's because you're taking a test online, and so
Right.
it's already been programmed a certain way, and it gives the wrong direction of the math if you don't define your groups the same way they define their groups.
Right.
So
But we
your
know-
test statistic would come out with a negative, and theirs came out with a positive. So it tells you exactly which way to do it.
I just remember
But the first thing. Sorry.
That well, it was a while back. We got it right, but it was exactly what you said. We just plugged in the wrong one.
Mhm.
Yeah. So you want to be careful. Yeah. So be careful. But the first thing you have to determine is you've got the two groups. So the next question is, are they dependent or independent? Because that also affects the outcome if you use the wrong Excel spreadsheet.
So
we've got to decide: are we doing match pairs? Or are we doing independent?
we're doing independent
Mhm.
because people
Okay,
don't
nice.
own. Most people don't own cars in both places. I would. That would be my thinking.
Yeah, I mean, well, it's basically if you picked up, if you randomly selected a red Hummer in New York, are you going to therefore go to California and find that exact basic
can't.
prototype of
Yeah.
a red Hummer? That came off the same line and it's the same color. I mean, it's like,
Yeah.
no, we just randomly selected some from New York
Yeah.
and we randomly selected some from LA. So they're totally independent of each other.
So it's C.
C.
C, 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 C.
C.
It's a C.
Calculate 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York.
I'm opening the sheet now.
Confidence
And
interval.
it tells you up in that, in the upper one, it says Los Angeles is group 1.
Yes, and LA and New York's group
Okay.
2.
Nice.
Input your
Okay.
answers in the lower bound and upper bound. So
Okay.
So it's listing price we're looking at.
yes. Wait. Did I get that right?
Wait, LA is 1?
LA's
Yes.
group 1.
Okay.
What numbers did I get?
This is a lot of data. Oh, wait, it is a larger sample.
Yeah, the nice thing is on the exams, usually they put the data sets, they make them relatively small. So it's easy to tell if you, because it's always, I've had it a couple times where it opens up and I didn't notice that it opened up and it started on row 4.
Oh, yeah.
And so I didn't get all my data in. Or I think I'm at the end anyway. And so it's like when there's so many, it's hard to make that decision. So it's like they usually try and keep it small so it's real obvious. You're like 10. Okay, I've got 10. You know, like you can get a visual like I did it right. I got them all in. So, but on these they don't. Usually it's big chunks.
Yeah.
Oh,
All
I did
right,
something wrong. Great.
so input the lower bound. I have negative 423.238. Is that what you have?
Yeah.
Oh, okay.
Yeah, which is telling the negative in this case is telling you that on the lower bound is saying the average is New York is more expensive by $423. To the upper bound, the average is LA is more expensive by $5,417. So that because you're doing a subtraction, so it's the negative means the New York's going is higher because you do the subtraction and so you're doing LA minus New York. So to get a negative saying the New York is costing more.
So I
That's
got
interesting. It's
different.
nice to know more about what it is.
Yeah, I got different numbers.
Are they very far off or like somewhat close?
For the confidence interval,
Yeah.
I got negative 649 and positive for 7279.
I wonder if you copied and
Did you-
pasted the data just slightly wrong.
I must have, would be my
Yeah.
guess.
Are you and you are in 2 independent samples, right? You're not in the match pairs.
I'm in the paired. That's the problem.
Okay.
Wah,
That's the
wah.
problem.
So what did you get, Stephanie?
No,
I
that's
I got negative 423.238.
And 5417.
417.336.
Okay. Whew.
perfect.
Yay. Okay, so lower bound, negative 423.238.
This is a hefty quiz, but this is like so good for test prep.
Mm-hmm.
It
5417.
is, and but it doesn't cover everything I think you're going to need to know. That's why I made those two exam reviews. And
Awesome, thank you.
I corrected my mistake.
I saw the
I
email
don't know,
for
right?
that.
Yeah, but look at the second one, because after I corrected and send out the link, then I sent out the link where I can edit I sent out this link on my Zoom account for editing instead of the viewing. I'm like, oh my gosh. Like you said, this struggle is real. I'm like, hallelujah.
It's awesome.
Like you get so like, oh my gosh, I got to get this out. I got to get this out. I get this out. And Zoom takes a while to render. So I was like when I finally got the email, I just grabbed the URL and threw it out there. And I'm like, yeah, I didn't read that close enough. I grabbed the wrong URL.
Oops.
Like, why doesn't that email just have one URL? Why does it have like 4? I just give it what I need. So anyway,
Oh man,
That's awesome.
funny.
anyway, it's all correct. It's on the email, or you can go to the announcements. It's updated there.
Okay,
Cool.
cool. Thanks.
Okay.
I don't know why I said that wrong.
It happens.
You're human. It's good to know.
Way too often.
Okay. Let's see. Close. I had to close some of these Excel sheets because
I know it's like getting
We're
messy.
getting down there, you guys.
Yeah.
We're down to the last.
Okay. So bone, we're going to do bone density. So we're going to do the ANOVA
Good. Yep.
because there's 3 tests
Question.
here.
Oh,
Question?
okay. Yeah, many studies have said.
Yeah.
Okay, I didn't read it yet, so okay.
That's okay. I did the homework, so I was like, oh,
Oh,
did this
okay,
one
I'm like,
already.
how did
Boom.
Already. Okay. So exercise stresses bones to get stronger when steady. Go rats. Okay. Calculate the test statistic. Let me open up ANOVA.
Yeah, and see that flow chart's kind of nice. Well, not you, but you're like, okay, I'm ANOVA, and so you're like, here's the hypothesis test, here's the requirements.
Yeah.
It just kind of keeps it all kind of organized for you.
So great.
And ANOVA, it doesn't matter the order. Unlike the 2 sample where you're doing the subtraction, the math's way different for ANOVA. So the order of what's group 1, group 2, or group 3 doesn't matter.
That's nice.
Oh, good. So question 25 is ANOVA. Boom.
Yes. Yeah. Yeah. You answered it. Yep. Nice work.
I worked so hard. Hopefully I do.
Really
I usually don't do well on tests. I don't know
Don't
why.
say that.
I know. I just
Yeah, don't do that. Just go slow. Read for context clues. Make sure you watch those 2 videos and take notes on that. If there's something that you just know you struggle with, like I always get this type of problem wrong, like even that question 5, like I never remember how to find the margin of error in the confidence interval when I do a Z. Write down question 5, shorthand, and then write down how we did it. And then so when you get one that's similar, you're like, okay, I'm going to look back. That's on my notes. I can look back and I can see, oh, this is how we did it. Okay, I can work this, right?
Yeah.
So that's what I used to do. I mean, we rarely got a note card. In physics, we did. We'd get it. In my physics class in college, we got a note card because there were so many formulas. And a couple of them, I literally wrote the example. Like I didn't really write the formula. I just was like, because I thought I always mess this up. So I'm just going to have, when I get something similar, I'm just going to be able to, and then actually helped me relax taking the test a little bit more too. Instead of being like, I'm going to forget this, I'm going to forget it, I'm sure it is. I was like, okay, I've got this note card that's going to walk me through this type of question that I always seem to mess up on.
Yeah.
Well, the
So-
printout
That's
you
smart.
sent is amazing.
Yeah, I'm excited to look at that.
Like this.
Well, thanks. Sounds like
Yeah.
your brain and mine work probably a lot alike then, Catherine. So some people are like,
Oh.
yeah, whatever. And I'm like, oh,
That's-
mine's like,
yeah.
I have to have this like, and then, I'm like this process type of person.
Oh, yeah.
I am very literal, straightforward. Like the other day on Tuesday when we met, I was like, she said, draw a picture. So I drew a picture.
Uh-huh.
Like,
I have
Yeah.
to do that sometimes. My brain is very confusing. I range from being on like the highly creative end that's like very conceptual and imaginative to like I love spreadsheets and like I'm actually really enjoying stats and like you know that kind of stuff.
Yeah.
I don't understand myself.
It's
All right,
good.
so
It's good.
the,
right, so-
the statistic is F,
Yeah,
correct?
F statistics. So I have
F.
7.978.
Yes.
Yep. Yeah.
And then p-value I have 0.002.
0.002.
Yeah, and an F statistic is a right skewed distribution, so it's,
Oh, that's right.
it's not a bell curve. So it's kind of an interesting,
Oh.
and we'll see another one like that when we do proportions next unit.
Oh, cool.
Okay, so this is how my brain works as well. Before I even get to question 28, I look at that p-value and I just go through and I go, would I reject or would I fail to reject?
I would reject.
We reject. Because the p-value
so
is low,
there-
reject HO.
So there is sufficient
Yeah,
evidence.
exactly.
So we
Okay,
can
so
rule
now that
out
you know
B and
it's
C.
sufficient evidence, yeah, exactly. You can it can only be A, D, or E. There you go.
Mhm.
And then what's the alternative hypothesis always for ANOVA?
It's at least one of the groups is different. It's not saying all
Right.
of them are. It's
Yeah.
So
All
it
right,
looks
so that's
like
what you're looking for.
it looks like D then.
Perfect. So that's how I'll do that because I'm like I am not reading 5 statements.
Right.
That is way, that is like my brain can't handle that. I'm like, so I have to immediately start eliminating stuff.
Yeah.
So I actually oftentimes in multiple choice, and this is probably being a little dyslexic, I can't read all the options. I have to almost answer it like it was a free response. Like I know there's sufficient evidence and at least one, and then I go through and I just look for that combination.
I like
think
to do
that's
the
smarter
same thing.
anyway. Like, I mean, we shouldn't just get in the mentality of like always having multiple choices to pick from. It's like we should understand the process well enough that if it were open question, we could do it, or open answer. we could do it.
Yeah. Well, plus sometimes in the multiple choice, they'll try and trick you like when on those confidence intervals, like question one or question 2. I mean, they love to frow in those chance statements and the probability
Yeah.
in the and I can't tell you how many people fall for them. I'm like, and I feel like I'm like turning red, going, it's not a chance statement, it's not a probability statement. We're only talking about the level of confident we are, and it's super easy. And so sometimes by answering it like you said as a free response, you're like, no, I wouldn't say chance, or no, I wouldn't say it like that. I'd say it like this. And because you know that's how you're going to say it, you won't fall into those traps either.
Yeah, for sure.
Okay, so next 29. How many times have we seen this direct flight information?
Yeah, this is the third time, I think.
Oh, is
Like,
it?
I'm just like,
don't even remember.
I am like betting money it shows up on the exam. We've seen it literally. Lesson 13, lesson 14, lesson 15. I'm like, holy Toledo, we have seen it the last 3 lessons. So I'm like, they love this flight data. I'm like,
I just know.
looks like, cute. I don't know. You'll have to tell me. You have to text me and go, yep, it was there. No, it wasn't. But I'm like, dude, this is like ridiculous how many times we've seen it.
That's funny.
We just need to make sure we get the right order, and in this, they want 90 days first.
No, they want 14 days first.
Okay.
Look at the very last line. For the next 4 questions, do 14 days minus 90 days for the analysis.
Ooh.
Wait, I have to read
You
the
see that?
question. Pressures of supply and demand.
Yes, it's the very last line.
Airlines raise the price if seats on the flight.
Okay, let me delete this.
Okay.
Let's do it right.
And you see there's two groups. So the first question or the second question. So you've determined it's for two groups. Now is it dependent or independent? That's the next thing we have to decide.
Oh wait, so it's independent, right?
Yeah.
So it's a independent sample set. So it's A.
No, not independent. Because look, the destinations they used in group one.
Oh, okay.
It's the same flight.
14 days in advance are the exact same destinations they used in group two when they bought it 90 days in advance.
No, that makes sense.
Yeah.
Because
they're using the exact same destinations to get pricing just at different time periods, those are dependent. Because I know what destinations are going to be in group two based off of what destinations are in group one.
Yes.
No, that does make more sense. I think I actually got confused about that in the in Adam's what was it, test review yesterday, because he like made up an example that like was kind of like this, but I don't know, like I don't know, it just confused me more. Yeah, even though I thought I like understood it pretty well, and I think I did, but it was a weird example. So
okay,
anyway,
so we're doing
so
a dependent samples test.
It was a good review, though. I'm not saying it wasn't.
And the
good. I'm glad it was.
Yeah.
1.685.
So it's a paired samples.
Did they have very many? Because the problem with doing a review live is that with all everyone's time zones and everyone's schedules, it's super hard.
Well, the problem with this is that some people couldn't join because Google Hangouts on Air limits you to, I think, 10 participants. So there were people sending him messages apparently who were like, oh, I can't get in because it was full.
Wonder why I didn't do like Adobe Connect or something.
Yeah, I think for the next review, like they should do something like that, probably.
But Zoom will let them put in 25 plus.
Oh,
so
yeah,
that's smart. Or PTAs for like 5 classes, and that's probably part of the issue too. So that's what makes that. So that's why, because usually, honestly, if you get 5 people at a review, you're doing awesome. Because again, you get all these time zones, you have all these schedules.
Right.
And so it's just really hard. That's why I went to just recording it, because I was like, it was like, okay, 2 people came or someone had to go. And I was like, you know what? I should just record it and let everybody just do it at their leisure. So it doesn't allow for you to ask questions. That's the only downfall. So that's why it was like, okay, Adam, you do one live and I'll do one recorded. And between them, we should be able to hit everything.
Okay, so 30. Did you do that yet, Stephanie?
I'm on it. Although I have a question, Sister Lemon, about some of this data. Yeah. So I noticed on a couple of them, like one of them in particular, it has the 14-day, but not the 90-day. How is that going to affect things? Like, do we just kind of like copy and paste it in and there are blank spots where there should be? Or, you know, is that, okay, just making sure.
So in the real world, what would happen is you'd say, all right, here's all the destinations, and then you'd send some, and you'll probably do this in your group, and you'll send one person or a couple people go get the information about 14-day advance tickets. And then you give the same destination to somebody else, and you go get the destination prices for 90 days in advance. And then those people come back, and somebody says, you know what, they won't sell a ticket 90 days in advance to that destination. So they don't have any data. So what happens is you put all the data in, and if you notice on your Excel spreadsheet, if you look at how the difference column's been programmed, it says if there is something in A and if there's something in column B, then do the subtraction. Otherwise, leave it blank.
Right.
I see. Yeah, because I put that in and it came out as blank on one of the differences. And I was like, that's not what Excel would do unless it's programmed that way. So
yeah, and it needs to be blank, because don't put in a 0. It'll mess with your values. It's not 0. 0 says, hey, there's no difference in price. And that's not what you're saying. You're saying there's no pair to go with this destination. So it needs to be kicked out.
Yeah, that's exactly what I was wondering about. Like, I feel like a 0 would like throw things off dramatically. So
it totally does, because it's information saying that the cost was, there's no difference in the cost, but that's not what you're saying. You don't have the data for it. So
Yeah.
it needs to stay blank.
Cool. So I
Okay.
have negative 0.142. Is that what you have?
For the T, I got 1.685.
Okay,
That's what I got.
put something in wrong then. Oh, and I closed the sheet. So many downloads.
Yeah, I had to start closing stuff.
Oh, I know why. Oh, that was a dumb mistake. So because there are blank spots on some of the data, I just like highlight columns like all at once, like using like little whatever you call them, hotkeys or whatever. And so if there's a blank spot, it stops highlighting and like, yeah.
Oh,
So I didn't have the full set of data for variable one, I think. So it's
Okay.
1.685 positive.
yes.
Okay, there we go. That was what I did wrong.
And the p-value. So we need to make sure we did the type of tests. And in this case, we're doing not equal to. Correct?
Yeah, it says perform. Yeah, because it says perform a hypothesis test to determine if there is a difference. So they're not saying
Yeah.
greater than or less than. They're saying, is there a difference?
So p-value is 0.0996.
96.
And your alpha level is given to be 0.1. So are you going to reject or fail to reject?
We are going to reject the null. There is sufficient evidence.
Okay. Okay, and the alternative was not equal, correct?
Yeah. So
So
there is sufficient. So it's B. So there is sufficient evidence to conclude that there is a difference in the mean cost of tickets. Okay.
good,
Agreed.
perfect.
Cool. And
Okay.
That's awesome.
Well, we know we got the last half of these questions right.
Yeah. Right.
Here, I'm going to submit.
Oh, do you want to go over the first couple or are you already good?
I think.
It wouldn't hurt before submitting.
Oh.
Okay, what'd you get for question 2?
Okay, wait.
I got B. We are 95% confident.
Good. Don't get caught in those probability or chance statements.
Yeah. So Adam gave a good trick. He said that if they mention the word chance, immediately rule it out. And same with like 90% of all people, like that's like probability. So rule that out also.
Yeah, that's right.
So
I think you must have watched my review. Those are the exact same things I said.
perfect. No, I'm still going to watch yours for sure. So
No, I'm just
yeah.
Well, there's a couple other things that they don't cover in this that I think will be on the exam, and maybe Adam went through those.
Yeah. All right.
Question 3, we got C.
Yeah, that's right. Yes, the distribution of means is normal since the data has been termed normal. Yep.
And then 4, C as well.
Yeah, they're independent. Yep.
Gosh, we're so smart. And then 5, we got D.
Yep, perfect. Yep.
Cool.
The larger your sample size, the less variance you'll have. So the less variance brings it in. Kind of basically like the law. It's basically the law of large numbers.
Yeah.
Okay.
And then 6, I think, is where you came on with the margin of error, which was 1.96.
And that's something this doesn't cover that I think you need to be really clear on is the definitions of the p-value and the central limit theorem and the law of large numbers. Review percentile ranking from Unit 1. They liked those questions. They had several on the last test. Anytime there. So I there's an example of that on the review, I think in the part 2.
So Stephanie, we got question.
I got 100.
Oh, I got 96.
Which one did you get wrong?
Which one?
28.
I put C.
I did not. I put D. I'm sure. Oh,
because it was sufficient.
Because there's 5 of them.
Yeah, I bet. Yeah, I just didn't have all 5 on the screen. I'm okay with 96%.
Okay. Well, and you're okay with understanding why it's D too, as long as you're okay with that.
I just clicked the wrong one.
Okay.
And I'm happy with pretty close to an A+.
Yeah.
Okay, perfect. All right.
Awesome. Thank you so much. That was so helpful.
All right. Take care. Have a good day.
Bye.
You too. Bye.
Bye.
She is
Oh,
awesome.
She is. That was a much more intense quiz than I thought it would be.
Yeah, I thought it would be very easy.
Yeah, but it's almost 10, so that took a solid like hour and something.
But
When
now,
did we actually start? Hour and a half for us, I think.
yeah, but doing this and then with her videos, I think I
We're
feel
well
good about the
prepared.
test.
Yeah, same. Like I felt really confident on the last one and didn't do as well, but I feel like this time it's going to be better.
Yeah.
So cool. Well, I'd better
Okay.
get going, but thank
Yeah.
you so much. And yeah, next Tuesday we'll talk after our meeting.
Yeah, that'll be great. I'll have questions and we can be
Okay.
responsible and stuff.
Okay, sounds good.
Okay.
All right, have a good weekend and good luck.
Thanks. You too. Bye.
Thanks. Bye.